An air suspension system employs an air spring or airbag instead of a traditional metal spring to provide support to a vehicle's axles. This video will delve into a comprehensive examination of the air suspension system, including its definition, operational principles, component structure, and application. The operation of an air suspension system revolves around the utilization of compressed air to adjust the height of a vehicle's suspension. Essentially, it employs the properties of air for a cushioning effect. As the vehicle encounters road imperfections, the airbags undergo compression and rebound, allowing the wheels to move freely. These airbags typically consist of rubber bladders, often constructed from textile-reinforced rubber or a composite of rubber and polyurethane. These materials are chosen for their ability to provide structural integrity, maintain an airtight seal, and resist corrosion. These rubber bladders are commonly referred to as bellows. Bellows are essentially columns of air confined within rubber and fabric containers, resembling stacked automobile tires. There are other variations, such as piston-type and elongated bellow-type airbags. When compressed, these airbags function akin to springs. An air compressor motor supplies the compressed air, and a height sensor detects changes in the suspension's height when the vehicle is loaded. Compressed air is then used to inflate the airbags, lifting the chassis away from the axle. To ensure a continuous air supply with minimal delay, an onboard air receiver tank is employed. The fundamental purpose of an air suspension system is to maintain a consistent vehicle height, even when the vehicle's load varies, and to enhance stability by absorbing road shocks. While the installation and configuration of air suspension systems can vary from one vehicle to another, their core operating principle remains consistent. In contrast to hydro-pneumatic suspension systems that use pressurizers liquid, air suspension systems rely on pressurized air. These systems have been in use for approximately 4 decades and have demonstrated their ability to deliver a smooth and shock-free ride. Today, they find widespread application in heavy-duty trucks, trailers, and buses. Modern electronically controlled systems in automobiles and light trucks often incorporate features like self-leveling, as well as the ability to raise and lower the vehicle's height as needed. History of air suspension system. Sir William Brush is often recognized as the pioneer of automotive suspension systems, earning him the title of the father of suspension systems in automobiles. The concept of air suspension systems dates back to the early 1900s. In January 1901, British engineer Archibald Sharp patented a method for creating a seal that allowed the use of pneumatic or hydraulic devices, referred to as a rolling mitten seal. He also applied this invention for the purpose of air suspension on bicycles. In 1909, a company called Air Springs Limited commenced the production of the ASL motorcycle, notable for featuring pneumatic suspension at both the front and rear. Rear suspension was an uncommon feature in motorcycles of that era. On January 22, 1901, William W. Humphreys patented the concept of a pneumatic spring for vehicles, which consisted of right and left air springs longitudinally channeled along almost the entire length of the vehicle. During World War II, the United States began using air suspension for heavy aircraft to save weight. Air suspension systems were also applied to heavy trucks and aircraft to provide self-leveling suspension. This innovation allowed the height of the axles to remain independent of the vehicle's load. In 1955, the Citroën DS introduced 4-wheel hydro-pneumatic suspension. Air suspension was experimented with on EMD's Aerotrain in 1956. General Motors developed air suspensions for trucks and airplanes, drawing on their World War II experience. In 1957, General Motors introduced air suspension on the Cadillac Eldorado Brougham. Soon after, several other car models, including the Rambler Ambassadors, American Motors, Cross Country, Station Wagon, Eldorado Seville, Borgward P100, and Mercedes-Benz W112, began utilizing self-leveling air suspension systems by the early 1960s. Rolls-Royce followed suit in 1965, and the Ford Motor Company adopted air suspension technology in 1984. In 1986, Toyota launched the first electronically controlled system, a semi-active full-air suspension system. By 2013, Tesla's Model S started offering height-adjustable air suspensions, marking a significant advancement in the technology's application in the automotive industry. Air suspension system definition. An air suspension system can be described as a suspension system that harnesses the qualities of air contained within a reinforced rubber column, often referred to as a bellows, to provide cushioning for the vehicle. These bellows are engineered to endure high-pressure air and undergo inflation and deflation as air is introduced or released, respectively. Unlike conventional metal springs, these bellows are employed to absorb shocks in the suspension system. To adapt to varying vehicle load conditions, air suspension systems incorporate height control valves that gauge the necessary amount of air to be supplied to the bellows. Main parts of an air suspension system. The air suspension system consists of three basic components, namely the air compressor, air accumulator, supply line, airbag, the height control valve, and solenoid, which are the part of electrical systems. First is air compressor. The central component of the air supply system in the suspension is the air compressor. Its function involves pulling atmospheric air into the pump and compressing it to reach a pressure of approximately 240 megapascals, a process that includes filtration. Typically, the air compressor is positioned either on the vehicle's frame or within the trunk. Within the compressor, a component known as a dryer employs a desiccant material to extract moisture from the incoming air before it is introduced into the suspension system. Second is air accumulator. Certain advanced compressors require a storage medium to hold the high-pressure air they generate. These storage mediums are referred to as air accumulators. Air accumulators serve the crucial role of ensuring a smooth and gradual transition between different pressure levels within the system. Additionally, a safety relief valve is connected to the accumulator to release any surplus air, maintaining safe operating conditions. Third is supply line. Supply lines play a vital role in transporting the compressed air to the airbags within the suspension system. These lines closely resemble standard high-pressure airline tubing and are typically routed alongside the vehicle's frame. Supply lines are typically constructed from rubber or polyurethane materials. However, in some cases, custom steel lines can be used as an alternative. These steel lines not only provide a more polished appearance but also offer increased durability and sturdiness. Fourth is airbag. Airbags are essentially simple rubber components designed to contain and hold compressed air. They are often referred to as air bellows. There are different types of airbags, including piston-type and elongated bellow-type variants. These airbags leverage the compressive properties of both air and rubber to absorb vibrations and facilitate the adjustment of the vehicle's height, either raising or lowering it as needed. To achieve this, compressed air is introduced into the airbags, inflating them and subsequently altering the suspension height. Typically, these airbags are positioned between the vehicle's frame and its axles. Airbags provide the capability to raise and level a vehicle that may be sagging due to towing or carrying uneven loads. Their adjustability according to the load allows for compensation when dealing with varying and irregular cargo, and they are commonly constructed from materials such as polyurethane or textile reinforced rubber. Fifth is height control valve. The height control valve serves as a sensor that detects alterations in the height of the vehicle's axle relative to its frame. While these valves are often mechanical in nature, modern vehicles also incorporate electronic height control mechanisms. This system can also be referred to simply as HCV. Now, after getting the knowledge about the parts used in air suspension system, now the question is how the system works. The air accumulator functions as the air supply source for valves that are affixed to the vehicle's frame. These valves are connected to the airbags via supply lines. When additional weight is placed on the vehicle, the height control valve HCV linkage deflects and adjusts the valve in response to the load, ensuring that the suspension maintains a consistent height. The valving mechanism of the HCV delivers air to the airbags based on the movement of the linkage. The supplied air inflates the airbags, restoring the suspension to its original position, thereby ensuring the correct ride height. The HCV linkage then returns to a neutral position, and the valves likewise revert to their initial state, securing the airbags to maintain the appropriate ride height. Conversely, when weight is removed from the vehicle or the suspension system, causing the load on the axle to shift back to its original position, air is released from the airbags via an exhaust port. The HCV linkage returns to its neutral position, and the exhaust port is sealed, trapping the remaining air inside the airbags to maintain the correct ride height. Applications or uses of air suspension system. Air suspension systems are generally used in luxurious categories of vehicles, including automakers such as BMW, Mercedes-Benz, Audi, etc. These are also used in heavy load-carrying trucks and buses for stability and control. Railways also use air suspension systems for its coaches to provide better cushioning and ride height. It is also used in sports car and off-road vehicles due to the adjustable ride height. I hope now you have the appropriate knowledge of air suspension system. Thank you for watching the video. If you like this type of videos, then you can subscribe this channel for more videos like this.